Hello everyone, and welcome back to Algebra 1 with Miss Betsy. Today we're going to be talking about how we solve equations that contain fractions, and we'll see that while equations that contain fractions can be intimidating at first glance, it's really not a difficult thing to deal with once you learn the methodology that I'll be presenting to you in just a moment. Hopefully it'll be a pretty straightforward presentation because I've already done this lecture once today, looking right into the camera without it being on record. So hopefully it will go somewhat more smoothly. So let's pray. We'll have our lame joke and dive right into the lesson. God, I thank you that you are Lord, and I thank you that you are intimately acquainted with all of our ways. Father, I thank you that you know me, and I thank you that you give me the ability to learn and to teach others. Father, I ask that those on the other side of this YouTube video would gain in understanding as a result of having spent the time watching this video. Father, help us to honor you in all that we do. In the name of Jesus, amen. Okay, since we're talking about school, tell me what it is that is a snake's favorite subject. And I'm sure the guys have already come up with the fact that, of course, a snake's favorite subject is history, because the snake goes sss. So, why in the world would we even need to deal with equations that contain fractions? Well, the reason for that is that there will be any number of times that you need to deal with fractions in real life. So I'm just going to go ahead and track pretty closely with our book, which, by the way, is Algebra 1 for Christian Schools, published by Bob Jones University Press, 2nd edition. Doesn't track exactly with the 3rd edition, but regardless of what book you're using, you can gain value from this lecture. And on page 154, which is section 4.7, Clearing Equations of Fractions, we have this real-life word problem. The coach has developed a drill that requires a rectangular field with the width being 1/3 of the length. The perimeter of the field is 280 feet. What length and width should the field liner mark off? So we have a real life problem. We have a rectangular field, and a rectangular field means that we have 2 equal lengths and we have 2 equal widths. Now, we don't know what those length and width are, but we know that they're going to be the same, and we know that the perimeter, or the distance around that field, going the whole length around it as if it were a fence, that perimeter is equal to 280 feet. So before we can solve an equation and determine what the length and width is going to be, we need to come up with that equation. Well, our problem says the width is 1/3 of the length. So the width is being described in terms of the length, so we're going to let x be the length of the field, because that is what the width is being described in terms of, the length of the field. So if the width of the field is 1/3 the length, then 1/3 times x has to be the width of the field. Now, what equation can we come up with utilizing the perimeter and the length and the width of the field? Well, probably most of you will remember from pre-algebra that the perimeter is twice the length plus twice the width. You could also say that the perimeter is twice the length, the quantity of the length plus the width, but they don't even want you to remember that much. They simply want you to understand that perimeter is the distance around. So it's going to be, the length is, not w, the length is x, and the width of the field is 1/3 times x. And they just want you to say length plus width plus width, as I write a w instead of an x, is equal to 280 feet. 2 lengths, 2 widths, put them all together, and you have a 280-foot perimeter. Now, What you could do is say, okay, that's 2 2/3 x, that's 8/3 x, multiply both sides by the reciprocal, which is 3/8. But they don't want you to use that methodology. The title of the chapter is what? Not the title of the chapter. The title of the section is Clearing Equations of Fractions. And what they're talking about here is eliminating any fraction before you solve it. And if you had simply added together and come up with 8/3 multiplied by 3/8, you're still using the fraction. They don't want you to do that. They want you to clear the equation, and there's one simple step. Multiply both sides of the equation, and I'm just going to say both sides by the LCM of the denominators of the fractions. How many fractions do I have here? Well, I have two fractions. The denominator is the same, so the least common multiple of the denominator is just the 3. So what are we going to do? We're going to multiply both sides of this equation by 3. I'm going to go ahead and just simply add this onto my equation as I have this written out. I'm going to multiply the left-hand and right-hand side of the equation by 3. Now we have a long distributive problem here, don't we? 3 times x is 3x, plus 3 times x again, 3x again. We have another plus 3 times 1/3. What is 3 times 1/3? 3 times 1/3 is equal to 1, isn't it? You have a common factor of 3 that cancels. Or 3/3 is always going to be equal to 1. If you cut a pie in 3 pieces and you eat 3 pieces, you've eaten the whole pie. Plus 3 times 1/3 x, which is x, or 1x, plus 3 times 1/3, which is x. Then we have 3 times 280, which is 840 feet. Look at the difference. That's really nice, isn't it? We have eliminated the fractions, or we have done exactly what our chapter is talking about here. We have cleared the equation of fractions by multiplying both sides of this equation by the least common multiple. Now, simply combine like terms. 8x is equal to 840 feet. I don't care what 8 times x is. I want to find out what x all by itself is. So I'm going to divide both sides of that equation by 8. And I find out that x is equal to 105 feet. Now, is my problem finished? No. My problem is not finished because it has asked me to find the length and width of the field. 105 feet is the length of the field, but what is the width? Well, the width of the field is 1/3 times x, which is 35 feet. So we have now found the length and width of the field. And right now I'm going to do something that I rarely do, but since I'm working on these videos from the comfort of my home, let me step out just for a moment. Sorry about that, guys, but since this is the second time I'm recording this video, I've got to make sure my dinner doesn't burn. Would you like to come over to my house? I'm making clam chowder for my husband. I'll see what my kids think about that. And I just heard a resounding yuck from one of them. However, I like it. They have leftovers they can have. Anyway, getting right back on, we have solved this equation that contained fractions by multiplying both the left and the right-hand side of that equation by the least common multiple of the denominators. Made it an equation that was very straightforward to solve. That's all that is going to be involved in this type of a problem. Now we started off this with a word problem that was made challenging to begin with because you had to come up with how in the world am I going to solve it. So let's just go and look at the first example in our book, which is after they've done this illustration, and see how it is that we're going to work with this equation that contains fractions. 2x plus 5 over 3 is 7. 2x plus 5 over 3 is equal to 7. Now if you have never seen an equation that contains a rational expression, that might be a little bit intimidating to you. And this is a good example of why I've said, don't just tell me when you see something that says x plus 2 is equal to 6, that x is equal to 4, because you have to know the methodology to use so that you're able to solve this problem. First thing to recognize right here off the bat is that we've got a fraction. And we're going to solve this by clearing the equation of fractions by multiplying both sides of that equation by the least common multiple, or the lowest common denominator of the fractions. Well, it's very easy when there's only one fraction. We use that denominator. So we're going to multiply the left and right hand side of the equation by 3. The purpose, of course, in doing that is so that that fraction cancels out because we now have common factors. 3 and 3, what do we have remaining on the left-hand side? 2x plus 5 is equal to 21. That problem is no longer the least bit intimidating, is it? Because you know that you have to find out what x is. First, x was multiplied by 2, then 5 was added to it. We're going to undo that by using inverse operations in reverse order. So first, we added this 5. We're going to subtract a 5 from both sides of the equation, and that will give us 2x is equal to 16. What's happened to the variable here? It's been multiplied by 2. The inverse of multiplication is division. When you divide both sides of that equation by 2, you end up with 8 being the value for x. Now, let's just check this mentally, see if we got the right answer. Here's our original equation. 2x plus 5 over 3 is equal to 7. Let's substitute this 8 in for the x. 2 times 8 is 16. Plus 5 is 21. Is 21 divided by 3 equal to 7? Yes, it is. So we have a solution to the first just blanket equation that we came up with that included fractions where it wasn't that word problem that we introduced the section with. So, pretty straightforward. Let's go ahead and see what example number 2 is. Example 2 says solve x over 4 plus x minus 1/3 is equal to 3 is equal to 3. Aha! Looks a little bit different now all of a sudden also, doesn't it? Another example where you don't want to look at that and just sort of say, oh, by the way, x is 7/5, which, by the way, it's not, but it might as well be 7/5, for as likely as it is that you're going to look at that and instantly come up with the answer, unless God has given you that specific ability in algebra, and He does that for some people. I, however, am not one of them. And if you are, you still need to show me how you arrived at that answer. We have an equation that contains fractions. How are we going to deal with this? Well, we're going to clear the equation of fractions by multiplying both sides by the least common multiple of the denominators. How do we find the least common multiple of two different numbers? Well, you prime factor those numbers. And the least common multiple is each unique prime number that's used as a factor, the greatest number of times it appears in any factorization. So the least common multiple is 2 squared times 3, which is 12. And that means that 12 is the smallest number that 4 and 3 will divide into evenly. What do we do now? We multiply both on the left-hand side, and I'm going to do bracket, just to make it really obvious. It doesn't matter if you use a parentheses or not. But we're going to multiply both sides of this equation by 12. Be very careful that you get that whole entire left-hand side of the equation bracketed so that you do your distribution correctly. First, you're going to have 12 times x over 4. I'm going to write this step out. This is optional for you. Plus 12 times x minus 12 times 1/3 is equal to 36. All I've done is distribute the 12. If you were able to say that 12 times x over 4 would be 3x plus 12x minus 4. At this point I'm okay with it, but the math will get a little bit more challenging, so you need to make sure that you can write out your distribution. What do we do now? We collect like terms, and that doesn't look right. Wonder if I did something wrong. Let me look. Nope, looks just fine. 3x plus 12x, 15x minus 4 is equal to 36. Add a 4 to both sides of the equation, and you end up with 15x is equal to 40. I don't care what 15x is equal to. I only care about 1x. I've multiplied x by 15. The inverse of multiplication is division, so we are going to divide both sides of that equation by 15. X is equal to 40 over 15. Is that correct? Well, it's correct, but it's not complete. You would get a minus 1/2 on that because rational expressions, fractions, have to be expressed in lowest terms. And this has a common denominator of 5 in it. You could do something like this: 5 times 8, 5 times 3. What I'm looking for is canceling a common factor of 5, and I have x is equal to 8/3. You end up with a fraction for the answer, but the math was not hard at all once you made sure that you understood how to eliminate the fractions, or how to clear the equation of fractions, and that you did that by multiplying both sides of the equation, because your equation must remain in balance. You multiply both sides of that equation by the common denominator of those fractions. All right? So let's do another example. This one is example 3 at the bottom part of that same page that we are working on, which is page 155. This equation now says solve x plus 2 over 6 minus x minus 1 over 3 is equal to 1/9. Okay? Pretty serious looking equation. Whole lot different than x plus 2 is equal to 7, isn't it? But you solve it using the same methodology, line upon line, precept upon precept, one step at a time. How do you deal with the fact that you have fractions? You remove the fractions by multiplying both sides of the equation by the least common denominator, or the least common multiple of those three fractions. The common denominator of 3, 6, and 9 is 18. How do we do it using our rules for least common multiple? The least common multiple is the product of each unique prime factor that shows up in the prime factorizations. Each of those use the greatest number of times it appears as a factor in any one number. 3 is used as a factor twice in 9, so our least common multiple is 2 times 3 squared, which of course is equal to 18. Now we figured out what our least common multiple is. We're going to multiply both sides of that equation by that least common multiple. Now, I do not recommend that you do this sort of multiplication in your head. You are setting yourself up to drop minus signs. You're setting yourself up to get your multiplication wrong. Take the time to show your distribution. You have 18 times x plus 2 over 6 minus 18 times x minus 1 over 3. And I was going to write that a different way that you'll learn to write quickly. Let me back up. 18 minus 18 times x minus 1 over 3. And here I'm just going to go ahead and say that 1/9 times 18 is 2. The reason that we multiply by the least common multiple is so that our denominators, our factors here, will be common factors that cancel out. 6 goes into 18 3 times. 3 goes into 18 6 times. Now that's a mess, so let's rewrite it. What do we have left? We have 3 times the quantity x plus 2 minus 6 times the quantity x minus 1 is equal to 2. That's a tad bit of a lengthy equation, but you know how to deal with that. I'm going to distribute 3x plus 6 minus 6 times x is minus 6x. Negative 6 times the negative 1 is plus 6. You see that by distributing that negative sign, the signs of those terms inside the parentheses flipped. You had a positive x, you've got a negative. You had a negative 1, you've got a positive. And then finish the equation is equal to 2. Collect like terms. Negative 3x plus 12 is equal to 2. We've added 12, so we will subtract a 12 from both sides of that equation, which will give us negative 3x is equal to a negative 10. Now, we don't care about negative 3x, I care about 1x. What's happened to x here? It's been multiplied by a negative 3. The inverse operation says to divide by a negative 3. And I have to divide both sides of that equation by the negative 3. Factors of negative 3 cancel. Negative divided by a negative is a positive. And we have, as our result, x is 10/3. Ended up with a fraction for the answer. But our algebra problem here was very, very, very straightforward. Once we realized that all we had to do to get rid of these fractions was to multiply both the left and the right-hand side of the equation by the least common multiple of those denominators. Okay? Now there's one more problem that I want to show you that they don't specifically use an example for, that you might be tempted to get tripped up on if you're not paying attention. So let's look at this and see what we have. This is problem number 12 in your homework, and you have 0.5x is equal to 0.3x plus 9. You say as you scratch your head, what in the world am I supposed to do? I thought we were talking about clearing equations of fractions, and we've got decimal numbers here. Yes, you do. But what is this? This is 0.5x. I said it that way on purpose. What does this actually say? 5/10 times x? 3/10 times x, doesn't it? That first spot after the decimal is the tenths place. That first spot after the decimal is the tenths place. Which means your denominator is a 10, isn't it? Same decimal place, same denominator. So we simply multiply both sides of this equation by the 10. But we have to multiply everything. You're going to be tempted to not remember that you have to multiply everything. 0.3x plus 9. What happens when you multiply a decimal number by 10? You simply move that decimal point 1 unit to the right. You have 5x. Now we distribute. 10 times 0.3x is 3x. And this right here is your temptation to make your error. When you forget to remember, well, that was not nice. Just put marker on my shirt. When you forget that you have to multiply that entire equation, and that entire side of the equation, by 10. So now rather than 9, we have plus 90. And you end up with a resulting solution to this equation once you finish the steps of x being equal to 45. So that's all you have to do when you're dealing with decimal numbers. What if we had an equation that looked like this? 0.7x plus 3 is equal to 0.14x. We have two different decimal numbers, but what do we have? We have 7/10. We have 14/100. Multiply both sides by the common denominator of 100, and that's how you would deal with this problem. So that is the end of this second recording of this lecture. If you have difficulties, shoot me a text. Otherwise, ask me a question when I see you in class on Friday.